well, you're supposed to be on, you're supposed to be on Zoom. I was like, okay, and then she was like, well, then you'll have to get the papers and bring them back and all this. I'm like, I was barely doing it in the other class.
Right. Gotta get off the phone, buddy. You gotta get off the phone.
Don't start it.
I'm starting.
Don't start.
Haley and I are gonna have a great class. Oh, where's the rest of? Oh, yours has no, it doesn't. Yes, it does. Does yours have 2 lines drawn?
Yeah.
Okay. There we go. So when 2 lines or rays meet, they form an angle. Or and I guess. You're more than 6 feet away from me. Okay. So when 2 lines or rays meet, they form an angle. If it's 2 rays, these are 2 rays meeting, forming an angle. If you have lines that are meeting, there are 4 angles being created. There's 1 angle, 2 angle, 3 angle, 4 angles. We'll learn more about those later on. What?
The last 2 lessons, this is easy as this.
Yes.
Like elementary type.
Haley did lesson 1 without even looking at the notes.
Yeah.
Where the paper at? Right now.
Well, right now we're doing this.
All right.
An angle measure is how far you would have to rotate one ray so that it lays or lies on top of the other one. So here are 2 angles. This one is smaller than this one because I would have to move one of them a shorter distance than I have to. So which one of these do you think is the largest angle? The purple one, the green one, or the yellow one? Yeah. So that bottom middle one is definitely the largest. Common angle measures, these are the most common angle measures. So starting off small, the smallest common angles. 30 goes up to 45, 60, 90, 120, 135 we don't see as much, so this is kind of a 180 is a straight line, we call that a straight angle. Then notice this means I would have to rotate all the way around to get here. We're not going the shortest distance, we're going where that little circle is. And then 360 if you go all the way around. 360. 90-degree angles are also known as right angles, so sometimes you'll see it like this. It'll have 90 degrees in there. Sometimes, well, actually, the majority of the times they'll just put this little box in here. That's what tells you it's a right angle. So it might not be listed as 90 degrees, but it'll have this little box in the corner. And that tells you that that's automatically 90 degrees. So I want you to go through and tell me which ones of these, one or ones, you think are right angles.
Well, class.
I'm glad you're here. So these 2, top left, top right, both of them are 90-degree angles. Angles that are less than 90 degrees are called acute. So acute angles are any angle less than 90 degrees. So go through your 6 options and tell me which ones you think are acute. The 2 middle ones. Why is this one down here in the bottom right not an acute angle? Yep, because it's going all the way around and not just in here. Nice job. I thought I would get somebody. Angles that are greater than 90 degrees but less than 180 degrees are called obtuse. I know. So go through these angles and tell me which you think are obtuse. Think so? That's a 90-degree angle.
Let's not shoot the little bit.
No way. Why is this one not?
We'll go all the way around.
So it's got to be less than 180. So it can't be past the straight line. So this one goes all the way around. So it goes past the 180. So it has to be less than 180 to be called obtuse. But good. That was my trick.
Thought obtuse was everything over.
So obtuse is anything over 90, but less than 180. So here's my 90-degree angle. It has to be anywhere. Try again. Here. Maybe. So it has to be anything between here and here. So anything between 90 and 180. So anything that falls in this area in here. So in summary, your 90 or anything less than 90 degrees is an acute angle. If it's exactly 90, it's a right angle. Greater than 90 but less than 80 is obtuse. And then last, I said this earlier, but if it's 180 degrees, it's called a straight angle. It's just a straight line. A straight line is called a straight angle. Don't look yet. Oh.
Do we get to keep these?
No, I'm gonna take them back and clean them.
You need that. You need that.
What, straight line? I just did sanitize.
Is what? Nobody has touched it. Oh, gee, I sanitized my hands when I walked in here. So you're going to draw an angle. It can be acute, obtuse, or a right angle. And then you're going to label it R, S, T. Don't worry about this middle thing yet. So you're going to draw an angle, R, S, and T. S has to be the end point of your two rays. So everybody's can be different and this will still work. So once you have your angle, you're going to put point X in the middle of those, or in the middle of your angle, and then you're going to draw from S to X and continue. It doesn't have to be in the middle, it could be wherever you want. So it could be over here, it could be over there, it could be right here. So somewhere in that angle, draw point X. So you should end up with a figure something similar to mine, except your original angle could be bigger or smaller. Yours doesn't have to look exactly like mine. Really good. Oh, who's here? Oh, I'm gonna clean this if I touched it. I did. I just cleaned first because I touched it. It's all sanitized.
All the viruses.
You what? I literally died.
Well, my uncle had.
So why do we have to do all this then? If it's very slim.
Because the CDC says we have to.
Well, the CDC shouldn't have school.
Guess what? You had the option to enroll in all online school.
I did, but then she allowed to.
You could be on Zoom right now.
Are you
Well, I
done?
still have to come to the paper.
Are you done?
No. We're on page 6, I believe. Yeah, we're on page 6.
We did start.
I need you to draw an angle like this, and you put a line in the middle of it. No pressure, but we're waiting.
Huh?
Yes. Although my mask is too big again. I just falls off. But if I tighten it, it's too tight. And then,
Does it matter what kind of angle?
nope, it could be obtuse, acute, or a right angle.
You go somewhere in man.
No, I did not.
You will see.
I spend my summers outside with my kids. My kids are very tan too.
My mom went to Florida. I asked her if I was her kid yesterday. Because she was so dark and I'm so light. And my mom's white. She's not mixed. I don't know how she gets it.
I mean, I don't burn very easily. Like, I'll only burn if I spend like 12 hours outside in the sun all day. Yeah. Labron, did you put your line in the middle or somewhere in the inside? Okay. Oh, I lost mine. Then we're going to take our protractor. See this little hole at the bottom? Everybody has a little hole at the bottom. I want you to put that on point S. When you put that on point S, see that little line? I want you to line it up with your bottom line. So line that line up with your bottom line. If your lines don't go all the way through the top of your protractor, you're going to have to extend it. Why do you have so many lines?
I don't know.
What is happening?
All of them have to go through it.
I don't know what's
Yes.
happening.
Well, you have 2 lines on the inside. You only need 1.
Oh, well, I don't know.
Unless you're not, or just forget about this line and use these 2.
Yeah.
Okay. So just forget about that line on the left. Did you get wireless charger? That's wired into the wall.
So why are we starting on? We get an iPhone 10, this is
Who cares? You're still plugged into the wall. Defeats the purpose is what I'm trying to say. Alright. So once you have that, you're going to find this line first. So we've got our little dot, our line's lined up. We're going to find where this line crosses. We want to use the bottom numbers, so the 10, 20, 30, 40, 50, 60, 70. Mine's at 75. So you're going to, oh, you're going to have to use your matrix. What? You know what? Yeah, a little bit. So I gotta get it split. All right, so you measured this one. Did you measure this one? So measure both your lines. Then we'll have to go in and measure. Okay, so if a class is this small, I don't know if we can do the Mona Lisa. Were you here when we did the Mona Lisa? That? Lame. You would remember it. It was a glorious day. It was. It's great. So a lot of you have found this from here to here. Some of you have found this from here to here. If you haven't, go ahead and do that, and I'm going to show you how to get this one right here.
Measuring the inside or just the line?
So you're measuring, so when you put this down here, and you go up to here to figure out what it measures, you're measuring this full angle. When you go to this line, you're measuring this angle here. And I'm going to show you how to get this one here. Just a second. Except I would put this 41 as this angle here. So you might move that down, because you found this what is right here in red on mine. All right, so now I want you to pick up your protractor or just spin it until your point is still at the bottom, but this time you're going to line up with the line in the middle. When you're lined up with the line in the middle, I want you to measure up to ray R, or SR, because that's going to tell you this measure right here in purple. So my example up here on the board, I had my whole angle was 75 degrees. The first little angle I found was 30. The second one, which is what you just found, or our finding, was 45. At the bottom of the page, you have a bunch of lines. I want you to tell me what you think about this angle and this angle in comparison to the entire big angle. What relationship do you notice between these two and this big one? Oh, write me a sentence or two. You don't know? Yes, about your O, yes. So don't use 30, 45, and 75 in yours. This one right here, you measure 1,000. And then you're going to rotate this here. That's this thing here. Yeah. It's pretty close. I have allergies. That's what it is. And I forgot my medicine at home, so it is what it is. What? I do take it. Something works. All right, so we're gonna follow.
this angle here. So this angle here. So you have 31 for this angle, 20 for this one, and 51 for this. What do you do about this angle and this angle in relation to this angle?
Never gonna answer any of your questions. I have to look and see. Should make you pull a massive over your nose. You're so scared.
No, I can't breathe. I say breathing treatment is just to be able to breathe. Mask in the heat.
So tell me what you decided about the relationship between the two smaller angles and the larger angle. What?
I put angles are down.
-5.
Mine's. One is bigger than the other.
They're not the same size, but what happens if I take 30 plus 45 on mine?
Yeah, you get 75.
You get 75. What did we measure the big angle to be?
75.
75. So if you take an angle and you cut it any way, shape, or form, we all cut ours differently. If you take these two smaller angles and you add them together, you get the larger angle. Is really what I was going for. Which leads us to the angle addition postulate. Postulates and theorems are a big thing in geometry. So angle addition, we have here angle 1 and angle 2. If you add these two angles together, that's going to equal angle PQR, PQR. Then you could do two separate things. If I tell you the big angle and a little angle, you can find the other little angle, essentially what these are telling you down here. But don't worry, we're going to practice it. So find the measure of angle 2 if the measure of XYZ is 86. Well, the first thing we need to talk about is, how do I know what angle XYZ is? So here's XYZ. If I start the first letter, so I'm going to start at the first letter, X. Here's X. I'm going to follow that to Y. So I'm going down this side to Y. Then I'm going to turn and go to Z because Z is the next letter in my angle. So angle XYZ, is it talking about one of the little angles or the big angle? The big one. So this is the big angle. And then the measure of angle 1 is 22. Well, angle 1 is labeled right here as angle 1. So I know this is 22. But the entire angle is 86. So this whole thing is 80. How could I find this little angle? Yeah, if we call this X, we're trying to find X. We know that 22 plus X has to equal the big angle, which is 86. We're going to do exactly what Kristlyn said and subtract 22. Yes. So, oh, I guess that was angle 2. So angle 2 is 64 degrees. There's a lot of algebra in geometry. A lot. Yeah. Sorry. find the measure of angle ABC. If I'm trying to find the measure of angle ABC, I'm going to start at A. I'm going to go to B. I'm going to turn and go to C. So I'm trying to find the measure of this little angle right here on the left. Oh, and it says find the measure of CBD, which we'll do in a second. But then they tell me the measure of angle ABD. So I want you to look at your paper and decide what angle is ABD, a little one or a big one. It's the big one. If I follow A to B to D, that's the entire angle. So this entire angle is ABD. If the entire angle equals 120, I got to add these little two angles together to equal 120. So I'm going to take 2x plus the other angle, which is 5x minus 6, and that's got to equal the big angle. These two little angles added together have to equal the big angle. As I was just told, combine like terms. So 120 equals 7x minus 6. What am I doing? Aha. Add 6 to both sides. X equals 18. Unfortunately, my instructions did not ask me to find x. I need to find x to get what I want, but the first thing it asked me to find was the measure of angle ABC. Well, here's angle ABC in pink, 2x. We found x. How am I going to find the measure of this angle? Well, again, so I'm going to take 2 times 18. So the measure of angle ABC is 36. I'm also asked to find the measure of angle CBD. CBD is this angle here. If I follow from C to B to D, it's talking about this inside here. So 5x minus 6. Would be 5 times 18. So the measure of angle CBD is 84. You can double check yourself. If you take these two angles that we just found, what should they add together to equal? $120. Double check. Is 36 plus 84 $120? Yeah. You ready? Complementary and supplementary angles. Oftentimes we see angles with measures that add up to either a right angle or a straight angle. These are called supplements and complements. Complementary angles are two angles whose sum, which means you add them together, and it's going to equal 90 degrees or a right angle. The two angles are called complements of each other. So if you look at this diagram here, the little box tells me that this is a 90-degree angle. This angle here is marked 45 degrees. What does this one have to be to give me 90? 45. So this one would have to be 45 degrees because I know when I add these two angles together, it forms a right angle. And 45 plus 45 is 90. The other type of angles, supplementary angles, when you add these two together, they form a straight angle, which is 180 degrees. They're called supplements of each other. So here, if I said this was 100 degrees, what would angle B have to be? 80. So whatever they are, they have to add together to form 180 degrees or a straight angle to be supplementary. See if you can do these two questions. So you're finding the complement of 58 and the supplement of 139. Bless you. So for the first one, the complement of 58, which means I have to take 58, add some number to it, and get 90. Well, 58 plus 32 is 90. So the complement of 58 is 32. The supplement of 139, if I take 139 and I add some number to it, I've got to equal 180 this time since it's a supplement. So 139 plus 41 gives us 180. On the next slide, we'll find algebra thrown back into our problems, right? So we know this is a right angle. What do I know about these two angles? What's their sum have to be?
29.
Oh, that's terrible. It's not even gonna work. All right. It's not even gonna work. Because the x's cancel. Minus 90, 0. Bad problem. I'll have to redo it. Nope, it's not gonna work. Forget this slide, just mark it through. It won't work, you get 0. That x can't be 0. So yesterday we talked about line segments having midpoints. So just as every segment has a midpoint that bisects it, every angle has a ray that bisects the angle. This ray is called an angle bisector. So if we look at this angle down here, if I want to bisect it, I'm going to just estimate where the middle is. So this would be my ray. So it's a ray because it has an endpoint here and it continues on one direction. And a lot of times they mark these congruent with little arches. So these little arches tell me that this line bisects it because it created two congruent angles. Put that back on. So here's our textbook definition. So here we have an angle. It's telling us that QA is the bisector of PQR. What that really means is that angle 1 is congruent to angle 2. So it's just separating the big angle into two angles of equal measure. So looking at this diagram, we're told that AT, ray AT, bisects angle CAN. So ray AT, start at A, go to T, this is your bisector. What that means is it's splitting angle CAN in half, which creates these two congruent angles. Well, if the big angle is 130 and I'm creating two equal angles, all I've got to do to find them is take 130 and divide it by what? 2. So angle 1 and angle 2 is 65. Double check, if you take 65 plus 65, it's got to equal 130 for the big angle. And last but not least, if ray AT bisects angle CAN, so same diagram. This time we were asked to find the measure of angle CAN, which is the big angle, if we know that angle 1 is 35.
The other one,
Yes. So if angle 1 is 35, angle 2 has to also be 35 because we were told that ray AT bisects the angle. So these angles are both 35. How do I get the big angle? Add them together. What's 35 plus 35? So the measure of angle CAN equals 7. Final answer.